Hello, can you hear me, guys? Okay. So yesterday we went through the different topics discussing about software development lifecycle, right? And software testing lifecycle. So we'll try to analyze the things again. As a testing point of view, what we do is whenever we work as a test engineer or tester or any part of testing related activities, we make sure, right? We make sure the software or application or product, right, is developed as per the client requirement. As per the requirement. Requirement is generally given by client only. So testing is nothing but generally we check the difference. So difference is nothing but actual and expected result. So with actual and expected result, we make sure whatever we have tested, whatever we are doing testing, we make sure there is no set of defect and the application is being developed as per the requirement. Whatever the requirement is there, it is being developed. Okay. So as an example, yesterday or day before yesterday, we saw if we have a calculator, so there is some expected and actual result. So if the difference is there, then your test result will fail and you will raise a defect. Else, if there is no difference, your test result is always pass. Correct or not? So if we find there is no defect, correct? Or if sometimes your test result fail, correct? What happens? If your test result fail, if test result fail, so what you do? You find a defect. Correct no? Here. If your test result fails, okay, then you find the defect. Okay, test result meaning we'll check today also what is this test result. Let's create a table to understand what we will be doing. Correct. So these things are the same. So we will create a test case. Test case is a document, okay, which gives idea about input field, expected result, actual result to validate the functionality. So what is the meaning? It's a test case is a document. Is a document contains input field, expected result, and actual result to verify or validate the functionality. So if we will understand what is test case, then what we'll be seeing here? We have an input field. So let's suppose we're taking as an input. What rest fields are there? With input, we have some expected result. expected result. What is actual result? Correct? And nothing but your test result. Okay, insert a table, correct. So here it is. We're giving some input. We are having some expected result. We're having some actual result and test result. What I said yesterday is your test result, it will pass or fail. A lot of things are there in the test case, but initially we'll understand. Let as an example, 10 plus 10. What is your expected result? Is nothing but 20, correct? So when you open an application like calculator application, anything, we'll see what happens. You open a calculator and what you do, you give input 10 plus 10 equal to 20. So the actual result also 20. The actual result also 20. What is your test result? Anyone, please? So generally, if your expected and actual result are matching, your test result is pass. Correct? So what happens if some scenarios, if your calculator is not able to multiply some value, let's suppose 10 into 1000, something. Okay. So expected result is 10,000. Correct. So what about, let's suppose actual result comes something like this. Like this. So there is some difference between your actual and expected result. So here your test result fails. So once your test result fail, what do you do right away? If your test result fails, what do you do? If your test result fail, you got a defect, is nothing but a difference between your actual and expected result. Then the defect, or sometimes we call it as bug. Okay. Bug and defect is same, because defect we say as a defect as a test engineer, but when we say it is to be fixed, so defect or bug to be fixed or resolved, then there is no defect left. And if there is no defect, the quality of the product is good, and hence your satisfaction level is good. Your client satisfied, you are also satisfied if you don't have a particular defect. Clear, guys? Since it is morning, there is no response. Anaga, Osok, Isin, Banu Prakash, Bhawa, Rahul. Some of you just, okay. So if your test result fails, if you have a defect to be fixed, and so these things is nothing but a general understanding of a test engineer or a tester. will make you're going through the process of finding out a defect, and hence you make sure whatever the requirement you had, and that requirement you're fulfilling the requirement, make sure the product is developed as per the requirement. Okay, so come to the point of discussion about the software development lifecycle. Yesterday we had 6 or to 7 phases of understanding. We are developing a Flipkart application, or it might be a web. So we are understanding the requirement and then start to analyze it. We're going through a study of what is our budget, what is the particular resources. Okay, how many resources, how many developers, testers, manager will be working on to make sure the product is being developed before or on time, so that there is no such a defect, or there is no no bugs available. So the quality is definitely good. And then design phase comes. In design, we have low level or high level. So low level, if the product having low set of design, and high level means generally we will be having different components enabled. Let's high level comes with web, and which can accommodate at a time, it can accommodate lakhs of people. When sometimes some kind of festive season comes, so in that festive seasons, people start buying the products from the Flipkart or Amazon website. So if high level design means it can accommodate a lot of people at the same time. Also, it helps for easier interaction, easier buying the product. So hence what is next is going to coding. Coding is something your front end, back end, okay, your middleware API. So a lot of development happens. So the coding to be done by the developer, and nevertheless, we are coming to the stage number 5 as a tester. We understand what is the application, what kind of requirement it is, and we are trying to test the application as per the client requirement, and there is no defect. If there is no defect, so the product is at a good quality and it is ready for deployment. Okay, it is being ready for deployment and it is ready for use. Deployment is nothing but a ready for use by consumers. And once it is done, we go for maintenance. Some changes are needed, some changes are implemented. You need to deploy the software. Before that, you have to do the set of development on the application, and then we'll start doing different type of testing, deployment, maintenance. So these things generally comes in a cycle again. So this is what we understood about software development lifecycle. And there are different set of models involved into that. Agile is one of the model which is very much popular. And currently it is being used in the different set of projects by different companies. If we say XYZ use Agile, whether it is Wipro, Infosys, Accenture, Cognizant, anywhere, anything, any company, the Agile methodology is being implemented. Waterfall, before some years back, the waterfall was very much used, but due to the drawbacks of waterfall, the Agile implementation came in. Due to that, it gives us, a good quality of product at a very small time period. So it also makes sure there is no defect. Customer satisfaction is much more in Agile model. And then we try to understand Yesterday, we understood what is software testing life cycle. It is similar like the development, starting from requirement gathering. We're trying to understand requirement gathering. Without requirement, you are not able to plan your testing. You can't do any kind of testing also if you don't understand. If you're understanding the requirement, you analyzed it, then you are doing a test planning. Test planning says how many resources you are planning to include for the testing project, what kind of testing activities you are going to perform, whether it is manual testing, whether it is automation testing, okay, whether how many resources, what are the testing servers, okay, resources. So a lot of things you plan. It's not like that. Also, some risk is also there. So there are different kind of things you plan before you start testing. And also it gives us idea when to start testing also. When to start testing, when to stop testing. Okay. So it's all about planning the test before we deliver a particular product. So a lot of things we do to perform a different set of testing processes. In testing, software testing lifecycle gives us idea about requirement analysis. It's not only requirement analysis in STLC, it was there with software development, requirement connection and analysis. Here, only requirement is collected and then we are analyzing. But here, we have already the requirement. So we are starting from the analysis phase. Then we are doing a test planning. When to start testing, when to stop testing, when we'll do manual testing, when we'll do automation testing, and then how many testing servers are implemented, and what are the resources are available, whether we have some resources. So all my resources are here. Osap, Anaga, Kishan, Krishna, Manuprakash. So all of my resources. Okay, Swati, Rahul, Prabha, Valadevi. So all are my resources, testing resources will be deployed for this testing project to do the testing activities. So we have different servers. In server, we will be seeing are nothing but your environments. Your system integration test is the first environment, first testing server for a tester. And once all the testings are completed, and it will be deployed to, or it will be moved to UAT. UAT is nothing but user acceptance test. It's another environment after system integration test. And after UAT testing is done, your user acceptance testing is completed, it will go to production. Okay. So this is what is a testing server meaning. But as we said, test case design or development, we just understood in the very first part, your test case is a document, correct? Test case is a document which gives us idea about input field, expected result, and actual result to verify or validate the functionality. What is the functionality here? We have an addition functionality. We have a multiplication functionality. So we are validating the or verifying the additional multiplication functionalities with giving different set of input and expecting some result. Here we have given 10 plus 10 as input. We're expecting 20 because 10 plus 10 is 20. We got actual result here in 20, correct? 10 plus 10, 20. So your test result pass. So this is nothing but it is called as a test case. So we are designing a test case. So the designing of the test case also is a part of your software testing lifecycle process, correct? And what you do, once your design is done, your environment is ready for testing. Once your environment or your playground is ready, you can play, right? If you can play, you will come and start playing the particular game or testing, whatever kind of testing you want to do, that will see. So once you execute the test or the test execution happens, hence you will be finding out your test result, whether it is pass or a fail. We make sure if it is pass, we'll go to test defect closure. But if some test is failing, so what you do, we go to correct. What you do once your test result fail? If your test result fail, you have to raise a defect. Okay, better you mention raise a defect or a bug to get it fixed, to get it resolved. Make sure there is no defect. So that is what you are trying to test the application in different ways, so that you are able to identify the defect at a very early stage. It might be at your very early stages, nothing but your system integration test environment, where at the early stage of testing is activated, it's your environment is ready, your test execution is completed, you got your test result as fail, you get it fixed, and then the deployment happens to UAT. UAT also, you go and check the different set of testing activities, and then the production, it goes to production. In production, you try to find the particular application is working fine as expected, and it is as per the client requirement. So once your test result, we makes your test result to pass or fail depending on the situation. Whether your test result pass only when you have a actual and expected result is matching. Already we saw, if you have a actual and expected result matches, your test result is pass. Actual result is, expected result is 10, actual result is 10, so your test result pass. If test result fail, in what situation test result fail? When you have a difference between your expected and actual result. There is a bug, get it fixed, no defect. That is what, as a test engineer, we make sure there is no such a defect. So once your defect is not there, you can ready for closing or signing off the particular test case or test cycle. You're ready for that. So your 100% your testing is completed. All test cases are executed. And after all, no defect is found. So now you can say you can close the particular test. Or you can give a sign off. Sign off is nothing but saying your test cycle is closed for that, and you have 100% tested, no defect is found. So we understood some planning activities. Whenever we say resource planning, in test plan, we have number of resources. We're determining the roles and responsibilities. Few of our people, we have, so here we can see Siva Reddy, some people join. So we can assign them as a, automation or manual tester, Krishna. So So make sure we different people in the meeting or different people in our team have different roles and they have a different responsibilities. Whether we're selecting a tool, it's manual, and whether three tools called Selenium, Tosca, and EFT are nothing but automation tools. So you guys have different set of tasks to perform functional testing as well as test automation. It's not only to that, we have to estimate the testing activities. So test effort estimation is one of the activities we have to plan also. So what kind of effort we have to put for doing the manual or functional or test automation activities. So before that, we should have a clear-cut plan, strategy to understand when to start testing, when to stop testing, how many resources will be there, what kind of tools we will be implementing, what kind of, when to stop, when to start, and how many servers will be there, how many servers. So we'll be able to test in different setup server. As I mentioned, SIT system integration test is nothing but your entry or initial stage of your test environment. And then once system integration test, your execution is completed, you go to user acceptance test that we'll deeply understand next few classes. User acceptance test says we have a alpha and beta testing. So we are doing alpha and beta and make sure our test execution is pass. There is no defect. Hence, whatever the test plan we have done, it is successful also. So every stage, every test roles are very important. So we make sure we are giving the effort. Also, it gives us the cost which the project has spent on you. So we are able to find effectiveness kind of the particular product. Moreover, it is being whatever the resources, environment, test limitation, schedules are determined, and we are ready to implement the test plan as well. So the next topic of discussion today, as I said, we'll have different type of testing activities. So what I said, so different type of testing is in general, we have some manual activities. Some manual activities means we are manually doing with our hand, where we don't have any automation script, automation tool. So generally, manually, a human is interacting with the application, doing a manual testing activities. So what we did here, in manual testing in the sense, we just kept the input, kept the expected result, actual result, and we did it manually. We completed here, you open the application. I only open the application. There is no tools involved, automation tool. So it is completely a manual testing. Manually generally, meaning there is no automation activities involved and a human interaction is being given to do the set of testing. So if you say manual testing, whatever you do testing, we do testing on black box. We'll see what is black box, white box, and gray box. White box is generally a developer activity. A development person will do this activity. Okay. Black box is as a tester will do. White box is generally says you can see the underlying code of the particular project. Okay, but you'll not be able to see the functional. You'll not be able to see the functionality. But here in black source, you will be able to see the functionality, but you'll not be able to see the internal coding structure. Internal code you'll not be able to see. That is called as white box. White box is internal code can be seen. Your functionality can't be visible to you. But here it is the coding, the coding, underlying coding is not visible to you in black box, but functional wise, you can see what is the particular functionality, how it works. You can be able to see and perform different testing. It is called black box. Might have heard about black box. Gray box is nothing but a mixture of, if you white and black mix, it comes as gray generally. Gray box. A developer, some developers can do the development as well as testing. That is for gray box. And in black box, as we said, software testing is divided into manual and automation. We do perform black box. Black box again divided into functional and non-functional. As I said, we are trying to test the functionality. So functional is something related to different set of testing activities, functional areas of testing. We do functional testing. Also, we do non-functional. Non-functional is nothing but load, stress, scalability, stability. Meaning, let's suppose a application, a Flipkart application, and now we feel a particular festive season. So what happens in that festive season? We don't know how many people from India or outside abroad will try to buy the products from Flipkart or Amazon. Okay, it might be 1 lakh, it might be 1 crore, it might be 10 crore. So suddenly the amount of people come in to buy the product, the load increases. Load is generally, it is a set of people, set of set of interaction to the different server with different set of people. So that becomes a load. And if the load increases, your stress will increase. Generally, you would have seen, generally, if you have some work, right? Some workload is there, generally in day-to-day activities. If your workload increases, your stress level increases. So that is coming under your non-functional testing. We'll try to see. So that is all come under performance testing. Performance testing says we have some load activities, load testing, and load testing. Generally, if load increases, your stress also increases. Scalability is something related to how much of scale, how much, how it will be performed after having too much of load and too much of stress. So also it gives us idea about stability, how much of stable the application behaves after having load and stress, and so that your application should be stable. Your applications should not be unstable. So this is all non-functional area. In functional, we try to understand your system test, system integration test. I said it starts with the unit testing activities. It starts with integration testing activities and system testing, so that we make sure whatever the functionality, whether it is addition or subtraction or multiplication or division, whatever, or square root, square, any particular functionality we have, or let's have a clear functionality. Clear is also a functionality. It's a function, it's addition, subtraction is a function. So from function, it is called functional. It is also called functionality. So we might have different unit testing. Unit is nothing but addition is one unit, subtraction is another unit, multiplication is another unit, division is another unit. So integrating all means taking all together, called integration testing. All are integrated to perform integration testing. And system, when everything are there, your system is ready. So it is called as system testing. Your system is ready. Your system contains each and every unit, also integrated with different functionalities. Hence, your calculator system is ready. You're performing some testing. 9 into 9 becomes 81. Oh, sorry, 9 into 0 it was there. Let's suppose 9. divided by 6 is 1.5. So this is what you are trying to test each and every unit, each and every functionality integrated together. You can test the particular system called system testing. So here it is functional, we have system testing, integration and unit, but non-functional, we have performance. In performance, we have load. Load, I said, when we say a application, Amazon or Flipkart, there is some amount of load is given. Let's suppose 1 lakh or 10 lakh people can come in, but whenever 1 crore people comes in and try to buy product, it becomes stress to that. Okay, stress testing. So load will get balanced only when we are balancing the particular load in the server. Then this stress testing will not happen. So stress will not come. And the testing we do perform, because we'll generally a particular at a particular room or a particular house can contain 10 people. Let's suppose 100 people come in. So you will get stressed. You're stress testing. Then only you will be trying to test the particular functionality with a lot of stress. And the scalability is to scale to check how much of load and stress can be checked with scalability and stability of that. So whether your application is not getting stable after having different set of load and stress. So whenever we talk about functional, we went through understanding unit is addition, subtraction is all unit. Integration means taking together its integration, and system is nothing but your calculator itself a system. So we do perform the calculator system testing. We have incremental, we have non-incremental. This understanding, this concept will understand later classes. And today we'll just do in the defect life cycle or bug life cycle, we'll just understand, correct? So any doubts so far, guys? Anywhere, anything?
No, sir, but actually most of the testers using the retesting and regression testing, but here not.
Yes, we'll do. Because in system testing, when we'll go to system testing, we'll do and perform. This is just a picture. We're not getting into the deep of system testing. And in systems testing, what we, as you said, retesting is to be done only when we have a particular defect is identified, right? When you say a defect, correct? A defect, we got a defect. When a defect at the very initial stage, when we found out a defect is being status as new. Once it is fixed by a developer, we retest, right? We have, before it is being new, we test it as a new. Here it becomes a retest. But regression, so we have already we have some testing activities are performed, but some existing functionality we tested. So we are going into the next phase of testing. We make sure in regression, we make sure our existing functionality is working fine. So that is what retesting or regression testing will come. So I can't say everything, each and everything, but as you said, retesting and regression testing, we do perform. And regression testing can be performed manually, or it can be performed by using automation, test automation. Okay, so retesting, regression testing says to test the existing functionality, to test the existing functionality with addition of new function. We add some functionalities, but we make sure we tested the existing functionality. Okay, and your existing functionality should work fine with the addition of new functionality. your existing functionality should not break. Okay, should not break. That is what we do a regression testing on that. And retesting is, as I said, once you test it, you want to retest. Why you do a retest? You build or you design some products, might have some defect. You fix the defect, make sure the defect is not occurred or the defect is not going to, or you are not able to find the same defect, similar defect. So you do a retesting on that. So whatever you do, you make sure there is no set of defect. Yeah, any doubt? We'll go through each and everything.
No, sir.
Yeah, we'll go through each and everything, each and every topics related to system integration, top down, bottom up, agile methodology. I just showed this picture. This picture doesn't says anything about agile, right? Agile methodology here. Agile methodology keeps us correct. This agile. Just I mentioned agile methodology. Agile methodology at least will take 2 classes minimum to understand the each and every kind of meetings we perform. Meetings are like sprint planning meeting, daily scrum meeting, like sprint review meeting, sprint retrospective meeting. There is some backlog refinement. So a lot of meetings are get involved to understand that. Okay, so we need 2 classes for this, but just a picture. But here initial classes will make sure you have a picture of testing, what the testing we are going to plan, we're going to perform. At the same time, the basic understanding we should have while we do perform testing. So these things, and test planning is not here completed with just 4 lines of 4 lines will not give us a test planning picture, but hence we'll just kind of a thought, okay, this kind of planning will do when we start a testing. We understand the requirement, we get into test plan, we start building down our test case design, start executing them, finding a defect, closing the test cycle, giving a cycle. Okay, so any more questions, please? We'll understand. Good to know. Yeah, good to know is you asked, you can ask anything, not an issue. If you know something, you don't know anything. If you're done, any doubts? Okay. So bug lifecycle plays a very important role while doing this, whether you create a bug in Jira or whether you create a defect in SPLM, whatever it is. So we have to make sure whatever the defect is there, it's being tested, it is fixed, and once it is fixed, it is no more there in the system. So we do that is what we do. A regression testing makes sure that the existing functionality is working fine, and we don't have the defect which it was occurring. And it can be regression testing. Nowadays, it's very much automated. Automation came into picture, whether it is on Selenium or with Tosca or with UFT, anything. So we do have a test automation tool involved to make sure there is no existing defect. And bug lifecycle says, when we find a tester find a defect, that gives a status as new. Once new, it is being assigned to a particular developer to fix it. A developer will get assigned a defect, and the defect will open. Developer will open the defect. And once developer opens, analyzes the defect, there is a chance that same similar defect is already given, similar. So it is called duplicate. If it is rejected is developer says, tester says it is a defect or a bug, but developer said it is not a defect, it is called, they'll reject. But sometimes some defect are there, developer says, so it is not a high priority defect. We'll understand what is priority, severity. So developer says it is a not high priority defect. It's a low priority. So it can be fixed on the later cycle, later sprint, or later releases. So once we come and see the different, whether we are getting into opening the particular developer opens it, it has to fix it. Once it is fixed, we have to retest the defect or retest the defect or a bug. So once it is retested, if there is no defect found, it is verified and we can close the defect. Else, if it is retested, we found the defect, it will go to reopen status. Again, a developer will open it, developer will fix it, developer will test and verify and close. So this goes in a cycle. This completely found in a cycle, starting from new, defect as a new to defect to close, complete in a cycle called defect life cycle. Life cycle, when a particular defect is born, defect to close or die in this particular cycle. So nothing but your defect life cycle. Understand each and every status, who a developer is responsible, who a tester is responsible. So everything will come and check. We'll be able to, find the defect life cycle. We'll implement in Jira also to understand that this bug life cycle. Okay. So tomorrow we'll go for understanding on different set of testing activities. Okay. Bug life cycle details we'll go through. Detailed things will go detailed into testing types, bug life cycle, and also we'll recap whatever we have completed so far. Okay. And in few later classes, next week or something, will be open up with a different set of tools to understand what kind of testing cycles, what kind of also we can include if tomorrow Agile and waterfall. If we have time, we'll be seeing the Agile and waterfall methodology, testing types again, deep into, and bug lifecycle. Okay. So any doubt?
No, sir.
Okay. Okay. Also, Krishna, Banu Prakash, Prabhakar, Rahul, Shiva, Satik, any doubt? Perfect. Sounds good. No doubts. We'll recap of things what we have completed. No worries if you are not able to understand something today. You can ask me tomorrow. Okay. And tomorrow we'll get into the deep of everything, whatever it is already covered. Okay.